Okay, this is our first example. So it's important when you're doing these double integrals, there's two things going on. There's the function going on right here, which is sort of the height of your terrain, and there's your region, that is the place where you're integrating. So it's always good to graph your region when you're doing a double integral, because your region is a nice two-dimensional thing. So in this case, my region is x goes from 0 to 2, and y goes from 1 to 2. So then x goes from 0 to 2, y goes from 1 to 2. That makes my region to be right there. That's my region. And then what I'm trying to integrate then is much harder to draw. So in like a three-dimensional space, with now it changes because now x is going that way, y is going that way. And so then my region of integration is kind of like right there. And I'm graphing some function, which could be like above or below that region, and then finding the volume, where green is determined by this function. This function says the height of my terrain in that region, and then my region is right here, right there. So let's then integrate this two different ways. One way we'll do x on the inside, one way we'll do y on the inside. So if we integrate, we'll do x on the inside, that's 0 to 2. Y on the outside, that's 1 to 2. Then we get xy minus 3xy squared. We're doing x on the inside there, y on the outside. The other way we'll do it is integral. We'll integrate y on the inside, which goes from 1 to 2, x on the outside, which goes from 0 to 2. The inside stays the same, minus 3xy squared, but then the dx dy becomes dy dx instead. Okay, so according to Fubini's theorem, I should get the same answer either way I do this. So I will try on the left first. So on the left, I always integrate the inside first. So keep that outside this integral the same. I like to put brackets after I've just integrated. Helps me remember what I've done. So I'm going to integrate with respect to x, which gives me a 1/2 x squared y minus 3/2 x squared y squared, because I'm treating y's as constants. That goes from 0 to 2. I still have a dy going on because I haven't integrated with respect to y yet. Okay, now when I plug in the 0, it'll all be 0, so I can just forget that. So I plug in the 2, and that gives me, plugging in the 2 gives me 1/2 times 4 is 2y. And then plugging in the 2 here, 3/2 times 4 is 6y squared. And I've got dy. So now I can integrate again. Integrating again, I have y squared minus 2y cubed from 1 to 2. That's equal to, plug in 2 for y, I get 4 minus 2 times 8 is 16, minus 1 minus 2. So that's negative 12 plus 1. That's negative 11. So my answer is negative 11, meaning the volume is 11, 11 below the xy plane, not above, since it's negative. Okay, now let's try integrating with respect to y and see if we get the same answer. So if we integrate with respect to y, the integral on the outside remains the same. Integral on the inside becomes 1/2 xy squared minus xy cubed from 1 to 2, and we still have our dx on the outside. Well, now plugging in the 1 and the 2, so then I have, I plug in the 2 for y, get 1/2 times 4, which is 2x, and then minus 8x, and then minus, when I plug in for 1, I get 1/2 x. I plug in for 1 here, minus x. And then I still have the dx. Let's simplify that. So then I have -6, but then minus this thing. This is basically minus a -1/2, which is minus -1/2 is plus 1/2. So -6 plus 1/2 would be -11/2x dx. Well, integrating there, I get -11/4 x squared from 0 to 4. So if I plug in 0, that just changes 0. I can forget about that. Plug in 2 for x gives me, like, divided by 4 times 4, so that's -11. And I get the same answer for both of them, which means all is right with the world.